Hello friends, welcome back to another new video of SKR classes and in the last class we have discussed about the modern periodic table on the board, and today we will be dealing with the trends in trends in at periodic table. So friends, according to the last class, we have discussed modern periodic table, and according to that modern periodic table, we will be discussing the trends in the elements in the according to the periods and according to the groups. So let's start with valency or valence electron. As you can see that here it is mentioned that in modern periodic table valency remains same throughout the group. That valency is something which remains same in a group, or you can say the number of valence electrons in a group are same, but in period it first increases till 4 and then decreases. It is this because that you will see that in potassium there is one electron, then according you will increase in the period, the number of valence electrons will go on increasing till the number in the fourth electron, till the fourth group, and then it will start decreasing till 10th, and then uh, according to the period it will continue like this. First increase then decrease. Then after that we can see that it is written in modern periodic table valence electrons remains same throughout the group, but in period it increases from left to right, as I have said. But in period it increases from left to right. If you move from leftward to of the period to the rightward of the period, that there will be a increase in the valence electrons. So now we will be heading ahead to atomic size or atomic radius. First, I would like to tell you that what is atomic size or atomic radius we are all talking about, and what it is measured in. The order of atomic radius is mainly in Armstrong. 1 Armstrong is here. You can see that it is mentioned that 1 Armstrong is equal to 10 to the power minus 10 meter. You can imagine how small it is. So now we will be telling you what atomic size is. Distance between the center of nucleus and the outermost, this is written outermost shell of electron, outermost shell of electron. So at why is atomic size relatable to atomic radius? You can get here from that the size of we have considered till now that an atom is circular in shape, and mostly have empty space in between, and hence is circular in shape, and the distance from the nucleus to the last present shell of the atom is called atomic size or atomic radius. Hence it can be said as both. Now I will tell you some facts and figure that why this trend will not be equalized, as if I will tell you the trend according to the period and the groups, and why are there some exceptions. First, there is ionic radius. That ionic radius is the size of the ions. Size of the ions will be changing as there you can see some examples, that like Na plus and Cl minus. Here Na plus is obtained by losing an electron from sodium. If you lose an electron, the size of the one shell will be obtained from the sodium atom, and there will be left with and will be left with only two shells. Hence this will reduce the size of the atom. And if you will see Cl minus ion, it will be formed by obtaining an electron from another element. Hence Cl minus will be will have a greater size or atomic radius than the chlorine element or atom. Now we will be moving ahead to the covalent radius. According to covalent radius, we have not studied till now that orbital overlaps, but I will lead you to some example that will get you clear that what is overlapping. We know that there is sharing of electrons in the covalent bond. Now for the sharing there is crossing over of the paths of the electron, which will reduce the distance of the center form. Hence you can see that here as mentioned, one second, here as mentioned in the overlap of atomic orbitals, here as I have mentioned that overlapping of atomic orbital, you can see that the distance between centers, covalent radius is basically taken by the distance between the center and their halves, which will reduce the distance. Now we will be focusing that what is the formula for counting this. You can see here that covalent radius RC is equal to half into D. That means covalent radius of any covalent bond is a half of their distance between their centers or nucleus. Now we'll be seeing that what is metallic radius. If we assume that these are two, if we assume that these are two, sorry, let me figure it again. If we assume that as I have told you in metals and non-metal chapter that electrons are flowing in the electrons are a flow of when electrons flow their charge, and in metals you will see that electrons come out of their atom and hence presence in free state electron, and the ions and the atoms become positive. Hence the distance between these two positive ions of any metal is known as the metallic radius. Hence the radius of metal will be large, greater than non-metal. You can obtain the formula from here. Rm is equal to d by 2, half into d, as we have seen here, that d by 2. And last on, the most important thing is the van der Waal radius. This is the most important case for exception in any for atomic, in any period for atomic size or atomic radius. Now we will see that what is van der Waal radius. As you know, in noble gases do not even ever form bonds. Hence the atoms of the inert elements are separated by a large distance. The distance between the atoms of any inert element or inert gas will be large, very large. Hence you can see here, as I have mentioned, that these are two helium atoms and they are separated by large distance d, larger than metallic radius and even larger than covalent radius. And ionic radius differs according to the case of non-metal, metalloids and non-metal. Now we will see that the formula for calculating this is also Rv is equal to d by 2, the distance between the center of these two helium atoms. Now we will proceed on to what is the variation or trend seen in this. This will be the last topic for us today. In the next class we will be dealing with some other trends that are followed in a periodic table. So here, as I have told you, that van der Waal radius is very large than metallic radius is large than covalent radius, and I have told you why is this so. Now variation of atomic radius. Why is there a variation of atomic radius among period moving left to right? As I have mentioned here with a diagram, you can see here, as I have mentioned here with a diagram. And as I mentioned that if you move downwards, if your movement is downwards, then there will be a increase in the atomic size as the number of shells increases, and the characteristics of metallic properties increases downwards. That will also be a thing that we'll be discussing further in this trends. And if we will be moving towards right of a period, then we will be discovering that the atomic size is decreasing. This is because of a very interesting phenomena or fact, as I will be dealing you here, that if we go on from left to right in a period, the the number of shells will remain same. There is a change in the number of electron or proton, but if you will see in depth, that the number of shells of every element in a period are same. Hence and if the number of protons in a nucleus increases, the force of attraction, you will see that there is a force, as I have drawn a diagram of an atom. I have drawn a nucleus over here, and this is an atom. The number of protons increasing will cause, as we have seen in the basic concepts in the earlier classes, that opposite charges attract each other, and the nucleus have positive charge, you all know, and the electrons have negative charge. Nucleus will be exciting the particles towards them, and hence the shrinking of the electron cells will take place. This shrinking due to larger number of protons will lead to a smaller size of atom. Hence as per increasing number of electrons, the size of if the cell is same, then the size will go on reducing. Now I'll be dealing the fact that R is inversely proportional to Z effective nuclear charge. R is the radius and it is 1 by Z effective. What is Z effective? Z effective is the amount of is the number of protons per number of electrons, or vice versa, you can say. Now among going down a group, atomic radius increases as number of orbit increases, as I have showed you, and H plus, H and H minus. H plus will be greater than H and H minus will be greater than H. As I have told you here that about if we discover the last page, that ionic radius Na and plus Cl minus, we have discussed about ionic radius, and this is a concept of ionic radius. And the lanthanoid contraction is the last thing we'll be discussing today. The radius of element, if you see a length, there two are there, lanthanides and actinoids. If we will see that the elements below lanthanides, there is no change in atomic size as if we go down a group. We have discussed that if we go down a group, there is change in, and there is a increase in atomic size, but there is no change in atomic size as we move toward groups after lanthanoids. So thank you students, and do subscribe, like and share.